Hey guys, welcome back to another A-level preparation video. This time it's going to be for the equation of a circle. Again, a topic that came up in GCSE, but there is some extra stuff as usual. So you're going to be doing things like finding the equation of a circle when the centre is not at the origin. If you remember rightly, the GCSE form of this equation was just x squared plus y squared is equal to the radius squared. Whereas in this case, we're going to have something slightly different. So again, that's what it looked like before, but that's because the centre was always at the origin. The actual equation of a circle looks like this. I know, look at that. Disgusting. Where A and B are simply the centre of the circle. Okay? Now, before we get into this, I've got a few things to mention. So one is, I got a comment saying basically, is this every exam question that has ever come up? The answer to that is no. So these videos are designed to give you an overview of the different styles of questions that you can be asked. However, we are going to go through every single past paper. So I don't want to do all of the past paper questions, because then when we come to do the past papers, it's kind of pointless, right? We don't have any past paper questions we haven't seen before. So that's my logic. The past papers will be done slightly later before your mocks. So this isn't literally every single question. Next two things, basically housekeeping. The worksheet is available for download on the Patreon. On there you'll also find the mechanics and statistics course, should you wish to purchase that as well. But for the worksheet, it's completely free. Click the link, you can download it, it's nice and easy and all organized. You can find all of the other worksheets as well free for download. In the description there's also the A-level playlist. These were all of the live lessons that I did last year, so they go a bit further on than we are going to get on with the A-level prep work. Without further ado, let's keep going. So these are the differences, the main differences. However, it says here, the circle C is the equation x squared plus y squared minus 2x plus 6y is equal to 26. Find the coordinates of the centre and the radius of C. And what you have to do here is actually find the equation of the circle. And how do you do that? Well, what you do is you use completing the square. I know, right? That comes back. So what I want to do, first of all, is I'm going to write the x's together and the y's together. So that equation can be written as x squared minus 2x plus y squared plus 6y equals 26, right? I haven't done anything except move the minus 2x to the front, which is completely fine because the order doesn't actually matter in this case. And what we're going to do is we're going to do completing the square for the x's and completing the square for the y's separately. So it's almost like I'm going to split this down the middle, and then I'm going to join it again afterwards. So for completing the square, what is that? Well, if you have an equation that looks like this, then completing the square is simply plus b over 2 squared minus b over 2, and then if you have a c, the c goes on the end as well. In this case we won't have a c, so it's actually quite small. It's just going to look like this for the x's. X, half of 2 is 1, so it's just going to be minus 1 squared minus 1 squared, and for y's it's going to be, so put a plus there, it's going to be y minus 3, so that is a 6, not a b, although it does look a bit like 1, equals 26. So what we want to do now is expand these and simplify them. So what we can do, if you fancy being a little bit lazy, which I certainly do, what we're going to do is we're just going to write the x minus 1 squared and then plus y minus 3 squared. And then what I'm going to do is I'm actually going to work out what minus 1 squared minus 3 squared would be. So realistically, I probably don't need a calculator for this, but just for the sake of laziness, we have minus 10. Minus 10 equals 26. Now, if you notice in the original formula, there is no constant on the left-hand side of the equation. We need to move that over to the right-hand side. So add 10 to both sides, and we get our final equation for the center. Whoops, not like that. Should be a plus between. Equals 36. And just so we're clear, A in this case is 1, B is equal to 3, and R squared is equal to 36. So if we look at what they're asking me, it says the center of the circle. The center of the circle is at 1, 3. And for part 2, the radius of the circle is just the square root of 36, which of course is 6. If you're wondering why it's not plus or minus 6, it's because the radius is a length and we can't have negative lengths. If I asked you to draw a line of negative 3 centimeters, you probably look at your ruler, look at me, and wonder what the hell I'm talking about. So that's why it's always going to be positive. So that first question we did was pretty much as simple as it can be. However, in your A-level AS mocks or in your A-level exams, they could chuck that at you. Just 3 marks, nice and easy, quick, quick, quick. The other 3-mark question they can ask you is they can give you the centre and they can say it passes through a point 4, 9. Find an equation for C. So what I like to do, as usual, is draw things out. So let's draw our circle first. I'm going to draw it over here and do my maths on the right hand side, like that. And this point in the middle is 2, 5. And then at this point over here, which is 4, 9, so again, it doesn't have to be super exact, there is a straight line. So actually there isn't, never mind. It just passes through that point. So first things first, I can actually write part of the equation, because again, remember the equation of a circle looks like this. I already have A and B. It's just 2 and 5 respectively. What I need is the radius. And how do I work out the radius? Well, have a look at this. They've given it to me. Technically, I don't need the radius, I need the radius squared, which actually does make our lives slightly easier. Now, what I can do is use good old-fashioned Pythagoras' theorem. So, if I draw my dotted lines going along like this, the width of this triangle is the difference in the x-coordinates, because x tells me everything I need to know horizontally, and y tells me everything I need to know vertically. So if I look at the x-coordinates, it goes from 2 to 4, then that means that width must be 2. And the height goes from 5 to 9, so that height is 4. Okay. So, in other words, a squared plus b squared equals c squared. That means 2 squared plus 4 squared equals r squared. So that's 4 plus 16 equals r squared. So that means r squared is equal to 20. So that means that is our answer. We don't need to square root it because we want r squared, we don't want r. That's a pretty quick question. And once you've practiced it, you won't even need to draw it. However, please, for the love of God, they like to screw you over. They like to throw curveballs at you in A-level maths. So drawing a diagram, it didn't take me long. Very quick, and with a pencil, I've done it even quicker. I can then see exactly what I need to know and what I need to do. Okay? So please, please draw diagrams. Here we have part A, which is the exact same as the previous question. But then we have a couple of extra points. And if you look at the marks, this is a 10-mark question in total. That's pretty big. Okay? Pretty big indeed. So let's have a look. First it says we have a centre of -2 and 3. So immediately I'm just going to write that in terms of the equation. And if you remember, the x is minus or whatever this is. So minus minus 2. In other words, it's plus 2 squared plus y minus 3 squared, and that equals r squared, which I don't know. However, using what we did before, we can simply work it out. Now, because this is a multi-part question, again, I'm going to draw out a diagram because that is a very important thing to do. You might want to draw multiple diagrams, but in this case, let's just draw one fairly big one because you can add to it over time. That's completely fine. It's not even recognizing that as a circle. Wow. Okay. And that gives me the centre of -2, 3. And this is 1, 8. So we can put it somewhere like, let's say here. Okay. Once again, all we're doing is we're working out the radiuses. So what's the difference in the x-coordinates? We go from -2 to 1. That's a difference of 3. Right? -1, 0, 1. 3 to 8, that's a difference of 5. So again, a squared plus b squared equals c squared. We have 3 squared plus 5 squared equals r squared. So that's 9 plus 25 equals r squared. So that means 34, yeah, equals r squared. So that answer is 34. 4 marks. Not too bad, right? Not too bad. Part B might be something that is somewhat more interesting to you. It says show that the point 36 lies on C, and what you would do back in the day, back in your old GCSE days, is subbing the x coordinate and see if the y coordinate is spat out. So if you had something like, let's say y is equal to 3x plus 2, you would sub 3 in for x and then see if that gives me y is equal to 6. Now you can still do that if you want in circles. The problem is you'd have to rearrange for y. Screw that. Here's what you want to do instead. Sub in 3 and 6 and see if it gives you 34. Big brain. So we have 3 plus 2 squared plus 6 minus 3 squared. What does that give us? Well, I like to do a few extra steps with this question just so the examiner can see that I'm doing something sensible, and then I'll do equals. And if you want, you can use a calculator, but 5 squared plus 3 squared, that is 25 plus 9, which is of course equal to 34. So it is part of this equation. It does lie on the circle. Now here's where it gets a bit fun. Now this is basically a GCSE maths question, believe it or not. It says find the equation of the tangent to C at 3, 6. So what I would like to do is probably put 3, 6 somewhere over here. And I'm actually going to erase some of this. However, in your actual exam, you won't need to actually erase it. And that center is minus 2, 3. And it says find the equation of the tangent at this point. So, give you answer in the form ax plus br plus c as well. That is the point 3, 6, like so. Well, we're going to do the same thing that you did back in GCSEs. You're going to use the fact that the radius will meet the circumference at 90 degrees. It will meet the tangent at 90 degrees. So if I find the gradient of whatever this is, I can do the negative reciprocal to find out what the gradient of the tangent is. Perpendicular lines, okay? If you're unsure and want a refresher on that, the last video was equations of a line where we did a lot of perpendicular stuff. So you can go back and have a look at that. But that's kind of the concept here. So I like to call it the gradient of r is equal to the change in y over change in x. So it's 6 minus 3 over 3 minus minus 2. So that is 3 over 5. That means that the gradient of the tangent, mt, you flip the fraction, 5 over 3, and then you make it negative. Not bad. Now, again, I actually showed you this new form in the equation of a line video. So normally you'd do y equals mx plus c, sub in m, find what c is, blah, blah, blah. However, when you have this form where they all need to be integers, it can be useful to use this equation instead. Y minus y1 equals mx minus x1, because you can get rid of fractions in one easy step. And if you're unsure, head back to the equation of a line video. So remember, the coordinate we need to use is the 3, 6, not the minus 2, 3, because it's a coordinate that lies on the tangent, not necessarily on the circle, although in this case it's both. So y1 is 6, so y minus 6 equals the gradient minus 5/3 x minus 3. And immediately, because I see here it says they all have to be integers, I'm going to times through everything by 3. So we get 3y minus 18 equals minus 5 x minus 3. Expand the brackets, 3y minus 18 equals minus 5x plus 15. And now lastly, but certainly not least, move everything over to the left hand side and we're done. X goes first because it just says that in the question, so plus 5x plus 3y, and then we have minus 18 minus 15. Again, if you would like, you can just slap it on a calculator. Ooh, careful of that. Minus 33. Minus 33 equals 0. 5 marks, in my opinion, not that bad once you get used to it. The good thing is that whenever they ask you to find the equation of a tangent, they have to give you a certain amount of information. 90% of the time, it's just the coordinate where it meets the circle. If that's the case, easy 5 marks, because the actual layout is the same. Gradient of radius, negative reciprocal, sub it into the formula, done. Those 2 steps all the time. Here's yet another style of question. Part A, in my opinion, is very, very generous. because if you have a look, they give us everything we need. So for part A, all we need to do is shove in the a and b, so minus 2 squared plus y minus 5 squared. And don't forget it equals r squared, not r. So 7 squared is 49. Just that's the only bit that I think you might miss up on, in which case you get 1 out of 2. So still pretty generous. Part B, you might notice this 6 marks and you might be thinking, Jesus Christ. But if you have a look at what the question states, it says the line y equals 3x minus 1 intersects C at 2 separate points. Find the exact coordinates. If you remember the discriminant video we did before, that means it's going to have 2 solutions. So what this effectively means is when a line intersects with another curve or a circle in this case, then that means the x and y values are the exact same. So what we can do is use simultaneous equations to work this out. Okay. So all I'm going to do is take this entire equation, and because it already says y equals, I'm not going to rearrange it. I'm just going to shove it in for y here. And it's going to give me a quadratic simultaneous equation. Okay, so 2 values for x, which I can then use to work out 2 values of y. Now that might sound really tedious and kind of overwhelming, but I have shown you before how to solve simultaneous equations on that white and black calculator that I thoroughly recommend. There's a link to it in the description, by the way, in case you just want to pop it open and buy it now. It's so useful, and I would say it's damn near essential for statistics. But anyways, let's continue. We have x minus 2 squared. And then y, we're going to sub in everything. So 3x minus 1 minus 5 squared equals 49. Now you can probably see already it's a quadratic simultaneous equation. So what do we need to do? We need to expand everything and then simplify. But just before that, just to make the algebra a little easier, I'm going to just simplify this bracket. So minus 1 minus 5 is a minus 6 squared. Was 49. Perfect. Now let's actually do the expanding. Expanding double brackets, I'm hoping you're completely fine with. I do go through it a bit quickly. So for example, x times x would be give me x squared, and then we'd have minus 2x minus 2x, that's minus 4x, and then plus 4. If you're struggling with this, let me know in the comments and I'll just type it out for you. Okay? And then obviously then you should definitely go practice this. And for this one, it's going to be 9x squared. Then it'd be minus 18x minus another 18x, that's minus 36x. And then plus 36 equals 49. Let's simplify what's on the left hand side. So x squared plus 9x squared is of course 10x squared. Then we have minus 4x minus 36x, that's minus 40x. Then we have plus 4 plus 36 is 40 equals 49. Now, of course, when we solve quadratics, remember, you need to move everything to one side. It needs to equal 0. So let's minus 49 from both sides real quick. So we have 10x squared minus 40x, and that's minus 9 equals 0. Now, let's use our calculator to work out these values. So you go to menu, go down twice and right once. It says equation/func. Equals, we're solving a polynomial. The simultaneous equation works for linear equations only. So it's kind of useless for us. So to polynomial degree, it's going to be 2 because it's squared, right? If we look, it's a quadratic. Polynomial degree 3 is a cubic, so something that has x cubed in it. And then 4 is quartic, which you won't use unless you're doing further maths. So 2, then we sub in the numbers. So we have 10 equals minus 40, whoops, equals and minus 9 equals, we get 2 pretty disgusting numbers, but it says find the exact coordinates. That's a bit annoying because what that means is we need to give it in exact form. So essentially we have to leave it like this. And you'll find that in a lot of kind of A-level questions you get pretty disgusting equations. Instead of or, you should technically write and because it's 2 separate coordinates. Yeah, probably didn't need to press equals to work that out, but hey ho. Okay, and now I like to split the thing down the middle. So we need to work out now the y values, and the really useful thing here is we have our equation already. So all we're going to do is sub in those two x values in to get our respective y values. So let's start with the one on the right, because what I can do is use the good old-fashioned answer button. So this is my answer now. I'll go to menu, go back up to calculate, or just press the number 1 on your calculator. We can do 3 times answer minus 1. And if you're really paranoid like I am, you can even put this all in brackets so you do it in the right order. That gives negative 100. That's pretty useful. And for the other one, we obviously can't do it. We're just going to have to do 3, and then we're going to have to type this whole thing in. 20 plus 7 root 10. Minus 1. We get that. You know what? That value is actually making me very suspicious. I'm going to type in this first one again. Minus 100, I just realised it shouldn't really be a whole number. So all that's different is this. Thank God I listened to my gut. Okay, so it's 50 minus. So get rid of this. 50 minus 21 root 10 over 10. So our two coordinates for A and B, it doesn't really matter which way around we put them, because they haven't actually given us any kind of indication as to what A and B are, as in, is A a lower x value, is B a higher x value. So in this particular case, we can't say which one's A and which one's B with 100% certainty. In some cases, they will make it obvious. They might say A is something and B is something else, like A is the x-intercept, B is the y-intercept, or something like that. So let's write these out just so the examiner can have no excuse to take away our hard-earned marks. And yeah, in A-level, we do get very ugly answers sometimes, but that is the way it is. (10 over 10, 50 minus). And that's how I'd leave my answer at the bottom. One final style of question. Here it says the circle has a centre 5 and k, where k is a constant. The line is a tangent to the circle touching C at this point. Find an equation for C. So in this case, you know, the kind of a previous style of question was we had the equation of the circle and we had to work out the equation of the tangent. Now we have the equation of the tangent and we need to work out the equation of the circle. So effectively, we're going backwards, which is completely fine. So first of all, again, let's draw our little diagram. You know, that wasn't actually a bad circle myself. So 5, k. I know that this point should technically be on the left-hand side, but I also don't care. I prefer to draw it from left to right. I don't know why. And we have our tangent like this, which has an equation of 2x plus 1. Now, let's use all of the information at our disposal. So what would we normally do? Well, normally we would find the gradient here and use that to work out the gradient of the tangent, and then we're basically done. Well, we actually follow the same steps, but kind of in reverse. We don't know the gradient of the radius, but can we work it out? The answer to that is absolutely we can, because we do the same thing but backwards. This line here, the radius line, let's call it, is perpendicular to the tangent, but that also means the tangent's perpendicular to the radius line. So the gradient of the tangent is 2, right? It's the number in front of x, which means the gradient of the radius, flip it over, so 1 over 2, and make it negative. Now, we need to work out k because we need to know the centre of the circle. So what can we do to work that out? Well, how would we normally work out the radius, the gradient of the radius? We would do the difference in y divided by the difference in x. Let's do that right now. So, difference in the y coordinates is 7 minus k over 3 minus 5, and that equals minus a half. Can you see the point? So now I'm going to actually simplify this slightly, just to make my life ever so slightly easier. I'm going to times both sides by minus 2 to get rid of the fraction, so 7 minus k. Now you can believe me if you want, but that's just going to give me plus 1. However, let's use our calculator to verify. We have minus a half times minus 2, 1. So now if we kind of swap this round, we have 7 is equal to 1 plus k. So k is just equal to the number 6. We're almost done. Now we actually know what the equation of the center is. The equation of the center, or the coordinates here, are going to be 5, 6. So in other words, we have x minus 5 squared plus y minus 6 squared. And what does it equal? It equals the radius squared. How do we work out the radius? We do Pythagoras' theorem. So what's the difference in the x coordinates? It goes from 5 to 3. So technically it's minus 2, but if you remember with Pythagoras, you square it. So you don't actually care. Also, we're using this as the length of a triangle, which means it shouldn't have negative components. And then 6 goes to 7, which is 1. So that means r... Actually, let's do it the other way around. 2 squared plus 1 squared equals r squared. So 4 plus 1 equals r squared, which means r squared is just equal to 5. That is our equation of the circle for 5 whole marks. Not that bad, I hope. So that's everything we're doing today. Again, this isn't literally every single question ever, but this is pretty much every style of question that's ever come up. For the rest of the questions, we're going to save those for when we go through every single exam paper in existence, which is going to be quite fun. We're going to do that towards your mocks. So we're going to go through all the Year 12 papers, okay? Hopefully that makes a bit of sense. But yeah, I'll catch you in the next one. But remember, the link to the A-level playlist is in the description, the link to the worksheets in the description, and of course check out the Patreon for the mechanics and statistics content as well.